Oh, it's Coach Goo here, and I just wasted 15 minutes of my life because I did this thing and I forgot to press record. Alright, so here we go, guys and gals. It's another fun-filled, action-packed, flipped geometry classroom video. Let me make sure I press record on both the voice and the video. Okay, here we go. Here we go. Today we're going to be learning about central angles and inscribed angles. We learned these vocabulary words yesterday. Today we're going to see how these would appear in some mathematical geometry problems. So let's start with central angles. Here we go. The vertex location. Where is it located? The center of the circle. It's going to be located at the center of the circle. So on my circle right here in this picture, is it point A, is it point C, or is it point D? It is point A. So if you said A, turn to that person next to you, give them a high five, just give them a big ol' slapperino. Point A. There you go. And the sides. The sides are two radii of the circle. Notice how, look, AC, that's a radius, right? AD, that's also a radius. That means they're both radii. That's the plural word of radius. You don't say radiuses. That's kind of hard to say. So we say radii, radii. And how do I label those two? That's going to be AC and AD. All right, so now, here's a special rule about the central angle. It is equal to the intercepted minor arc. Intercepted minor arc. Now, you see, look, the minor arc right here would be CD. Right there, CD. So, the measure of my angle, which is, how do I label that? CAD or DAC, your choice, is equal to the measure of arc. How do I label that arc? CD or DC. You can do it either way, but All right, so how am I going to see this in some problems? Let's take a look at these examples right below. I'm going to do the one on the left. You do the one on the right. So where is my central angle right here? That's going to be ABC, ABC. Angle's right here. So what is that marked as? What they tell me? It's marked as 3x. And now how am I gonna find x though? I gotta see what it's equal to. Remember, it is equal to the intercepted minor arc. My minor arc here is from A. I'm gonna draw it above A to C, right there. You see, it's cutting across A to C. What's the measurement of that AC right there? Arc AC is equal to 96. So I can say this is equal to 96. That 3x is equal to the 96. So I can use this information to solve for x. Divide both sides by 3, and x equals 32, and I am done. Boom. So now you guys, try the one on the right side. Next, we'll be working with inscribed angles. Inscribed angles, the vertex location is a point on the circle. So on this circle, which one would it be? And remember, it's a vertex, so it's going to be that corner piece of the angle. That's going to be point A once again. Point A is my vertex. And the sides are two chords of the circle. Look at this. AC and AD. Those are chords because both the endpoints are on the circle. So, how do I label that? AC and AD. Just like that. The endpoints of those chords. And now here's a special rule about the inscribed angle. The inscribed angle, the measurement is equal to 1/2 of the intercepted arc. Intercepted. So the measure of my angle, what's the angle here? How would I label that? It would be measure of angle CAD. You see how we go from C to A, the centerpiece, to D. Is equal to 1/2 the measure of arc. Where's the intercepted arc? That's right. Let me use a bright color. Right here, CD. It's 1/2 of that because this is an inscribed angle. All right. Now, the note in the little box here, you can also say that the arc is 2 times the angle. Is 2 times the angle. So this inscribed angle right here, bam, is 1/2 of that intercepted arc. Let's see how we use that in some examples. So over here, we've got on the left side. I'm going to do that one. You do the one on the right. So first, where is my inscribed angle? That is going to be right here. Angle ABC. So that is going to be this right there, which is 4x. Now that equals, remember, it equals half of the intercepted arc. So it's going to equal 1/2 of times, what's the intercepted arc? 120 degrees. So we're going to use algebra to solve for x here. So let's simplify the side on the right. So 4x equals 1/2 times 120. What's 1/2 times 120? It's 60. All right, so now I have 4x equals 60. So I just divide both sides by 4, and x equals 15. And that is it. So now you guys try the one on the right. Next up, we've got some special inscribed angles. So let's take a look at this diagram right here. Check it out. Both angles have a vertex that is on the circle. Nothing's changed there. They both have sides that are chords of the circle. Remember, look, we got CB and BD. Those are chords. We got CA and AD. Those are both chords. And they both have a measure that is equal to 1/2. There are so many types. Get this out of here. To 1/2 of the intercepted arc. So that would be this arc up here, CD. Because you see, both of these angles, they're using this exact same arc. All right. Now the relationship of these two angles to each other is that the two inscribed angles intercepting the same arc are, what's that word that means equal? It starts with a C. We used to use it a lot. Congruent. Congruent. So angle, what's one of my angles here? We got CAD. Look right there. CAD is congruent to angle. What's the other angle that I have here using the exact same arc? CBD. These are congruent. You see, because they both intercept the exact same arc, so they would both have the exact same measure. So let's take a look at the example. So we're finding x for each circle. Take a look on the left, okay, and then you would do the one on the right. So on the left, we've got two circles, two inscribed circles, two inscribed angles. Bam, angle ABD. That's right here, but that's 2x, right? Then we've also got over here angle ACD, but that's also 2x. So if I set those equal to each other, that's just gonna be 0. That doesn't make any sense. But remember, 2x also equals 1/2 of the intercepted arc, which is over here, 104. See, both these intercept this arc up here. Inscribed angles equal 1/2 of that measure, so it's 1/2 of 104. So now we can just use algebra to solve for this. So 2x equals, what's 1/2 times 104? That's 52. So 2x equals 52. Divide both sides by 2, and x equals 26. So now you guys try the one on the right side. Here's a hint. Two inscribed angles intercepting the same arc are congruent. So use that to help you solve the other question. And last up, we have an inscribed angle that is inscribed in a semicircle. Properties. An angle inscribed in a, what are we talking about? Semicircle is a right angle. So if you take a look on our picture right here, notice how the angle CAD, let me highlight this thing, CAD. Look at the arc it intercepts. That's a semicircle, right? That means that this angle right here, CAD, is a right angle, which means that the measure equals 90 degrees. All right, now something else you need to know. The two acute angles formed are complementary. That means they add up to 90 degrees. So my two acute angles are right here. ACD, that's one that's right here. ACD And then where's the other angle in here? Angle ADC, right here. Now remember, this is a triangle, right? And a triangle has 180 total degrees. So if this bottom angle CAD is taking up 90 of them, that means these other two, when they add them together, they have to equal 90 degrees. That's what this note is saying. How would I use this in some examples? Let's take a look at these bottom two. I'm gonna do the one on the left, you do the one on the right. So take a look. Our angle right here, ABC, right there. Let's see what arc it intercepts. Wow, that right there, AC, is a semicircle. So that means my measure of angle ABC, measure of angle ABC should equal what? 90, because it's a right angle. Because it intercepts that semicircle, it is 90 degrees. It's a right angle. All right, but what do they tell me that this equals? They told me it equals 9x minus 9. So I'm going to replace that with 9x minus 9 equals 90. And then from here, I'm just going to use algebra to solve for x. So I'm going to add 9 to both sides. That means 9x equals 99. And let me bring it over here. 9x equals 99. Divide both sides by 9. And x equals 11. Bam, there it is. Now you guys try this question on the right. Remember, the two acute angles that are left over are complementary. They add up to 90. So use that information to solve that question. But that's going to be the end of this notes video, guys. I hope you learned all about inscribed angles and central angles. But until next time, see ya, peace!